Namaste and a very good evening to all of you. I welcome you to my channel, The Outlier. My name is Mithun. In today's video, I'll be talking about a technique which is called as one-way analysis of variance. Even before I proceed to demonstrate how to perform one-way analysis of variance using StatCraft, may I request you to subscribe to my channel, also like and share my videos. Let me first begin by introducing the data set to you. As you can see here, this is the spreadsheet that has the source data. There are three fields here, namely flower ID, petal length of the flower, and the third field is species of the flower. This data set is popularly called as the iris data set. It is called as the iris data set. I have retained only one numeric variable and one categorical variable for better understanding of this analysis. What is the sample size in this particular data set? Let me scroll to the last record. If I scroll to the last record, you can see here 150, which means that I have information of 150 different flowers. Now, the question is, using one-way ANOVA, can we compare the mean petal length for the three species of flowers, namely setosa, versicolor, and virginica? Let me apply a filter in the first row. When I apply the filter and click on the drop-down menu, you can see here Excel displays the three species of flowers, the first one being setosa, second being versicolor, and the third being virginica. So these are the three different species of flowers that we have. When we want to compare the group mean for three or more than three groups, the one technique which comes to our rescue is one-way analysis of variance. What exactly do we mean by one-way ANOVA? Remember, ANOVA stands for analysis of variance. ANOVA is a statistical technique that is used to check if the mean of two or more groups are significantly different from each other. I'll repeat this. ANOVA is a statistical technique that is used to check if the means of two or more than two groups are significantly different from each other. Here, I'm interested in checking whether the petal length for setosa is the same as that of the petal length for versicolor and virginica. To perform the one-way analysis of variance, I will be using a software which is called as StatCraft. You can see here, this is the link for StatCraft. I've already loaded this particular data set into StatCraft. You can see the variables here, ID, petal length, and species. To perform one-way ANOVA, at the left-hand side top corner, you can click on what is called as the Analysis tab. Let me now go on to click on the Analysis tab. Once I click on the Analysis tab, you can see here StatCraft displays the menu that allows us to access different features. I will choose the third option from the top, which says compare groups. Here we are comparing the group means, therefore I will be choosing the third item from the top, compare groups. You can see here there's a drop-down menu. Let me go ahead and click on the drop-down menu. I'll now be scrolling down. Once you click on the drop-down menu, the different options that are present under compare groups is displayed. The second option from the top is analysis of variance. Let me again click on the drop-down menu here. The very first option that you see here is one-way ANOVA. I'm going to now click on one-way analysis of variance. The moment I click on one-way analysis of variance, what StatCraft does is it shows you a new window. Let me click on refresh button. So this is how this particular window appears. So this window is called as one-way ANOVA window. In the left-hand side, you can see the variable names that were present in the data set, namely ID, petal length, and species. In the right side, you have the option variable and category. Under the category section, we always specify the scale variable. The scale variable here is petal length. Let me click on the plus sign. You can see here, the moment I click on the plus sign, petal length in centimeter appears under the variable section. Now, under the category section, I will be choosing the variable species. So we have made our selections at this stage. I'll be choosing petal length under the variable section, and I'll be choosing the variable species under the category section. All that you need to do in StatCraft is select the variables. You don't need to remember what is the formula for one-way analysis of variance. You don't need to write one single line of code to perform one-way ANOVA. Once you select the variables, what is the next thing that we need to do? The next thing that we need to do is simply hit the OK button. StatCraft takes a couple of moments to process the analysis. You can see here, this is the output window. There is no other software that gives you the backend code. The only software which gives the backend code is StatCraft P. You can see here, in the backend, StatCraft is run the Python code. This is the Python code that StatCraft has run at the backend to generate the output for ANOVA. Let me scroll down. You can see here, this is the results of one-way ANOVA. This table is called as one-way analysis of variance table. There are 5 columns. The first column is DF, which stands for degrees of freedom. The second column is sum of squares. The third column is mean square. The fourth column, which is very, very important, is the F statistic. And the last column is the probability of F. Along the row, you have 2 different rows. The first row is called as between group sum of variation. I repeat, the row is called as, the first row is called as between group sum of variation. The second row is called as within group sum of variation. I repeat, you have the between group sum of variation and the within group sum of variation. So this degrees of freedom, namely 2, is the degrees of freedom for the first row. Similarly, 147 is the degrees of freedom for the second row. I will now jump to the third column, namely mean square. How do we calculate the mean square? Very simple. You have to take the number 218.32 and divide it by, my apologies, to obtain 218.32, you have to take the sum of squares divided by the respective degrees of freedom. So if you take the number 436.64 and divide it by 2, the answer that you will be getting is 218.32. This number 218.32 is called as the between group sum of square mean. It is the mean for the between group sum of squares. The second number 0.18 is obtained by dividing 27.22 by 147. When you divide 27.22 by 147, you'll be getting 0.18. When you take the ratio of 218.32 and divide it by 0.18, what you see is nothing but the F statistic. So remember, F statistic is simply the ratio of between group sum of squares to that of within group sum of squares. I'll repeat, F ratio is nothing but the ratio of between group sum of squares to that of within group sum of squares. The F ratio that we have obtained here is 1179.03. Finally, what we have is the probability value. This is very, very important, and this probability value is calculated for the F statistic. The probability value here is 3.05 into 10 power minus 91. So 3.05 into 10 power minus 91 is a very, very small number. How do we interpret the results of ANOVA? What we do is we take the p-value and compare it with the level of significance. If the p-value is less than 0.05, we reject our null hypothesis. On the other hand, if the p-value is bigger than 0.05, we do not reject the null hypothesis. As you can clearly see here, the p-value is very, very small. It is less than 0.05. And since the p-value is less than 0.05, we go ahead and reject the null hypothesis and conclude that at least one group mean differs significantly as compared to the others. Or in other words, you can say that the means for at least one species of flower is different as compared to the other two. I'll repeat. Since the p-value is less than 0.05, I will conclude by saying that at least one group mean is different as compared to the other two. Now the question is, for which species of flower is the mean value different? That needs to be investigated. Now there are two ways of investigating it. One is a graphical way of checking which group has a different mean, which flower species has a different mean value. The second one is a statistical way, which is called as post hoc tests. I will be showing both of these options in this video. Let me now show you the first way of investigating which is that group which has a significantly different mean. That is the graphical display option. I'll again click on the analysis tab. Once I click on the analysis tab, StatGraph displays the different features that are present in this software. I will head over straight to the option which is called as graphics. I can click on the drop-down menu here. I'll scroll down. The fourth option from the top is called as Boxplot. We will be using the Boxplot to check whether the mean petal length for any flower is the same or is it significantly different as compared to the other two. Let me go ahead and click on the Boxplot option. I'm going to choose the option refresh here. So this is the window for Boxplot. By default, it says multiple Boxplot. I can change this to what is called as grouped Boxplot. I'm expected to specify the X variable. X variable will be the categorical variable, namely species, and the Y variable here will be petal length in centimeter. I repeat, X-axis is species. We have 3 species of flowers, and the Y variable here is petal length measured in centimeters. I can now go ahead and hit OK. It takes a couple of moments for StatGraph to run the Boxplot. Looks like the Boxplot is ready. I'm going to now scroll down and show you the results of the Boxplot. You can clearly see here, this is the first Boxplot that we have, and this is the second Boxplot that we have, and finally we have the third Boxplot. Along the Y-axis, we have the petal length. You can see here, the first Boxplot is for setosa flowers. When you look at the central line, which divides the box into 2 portions, the average petal length for setosa is around 1.5. It is very, very low as compared to the other 2 species of flowers. So what we understand from this analysis is that the average petal length for a flower is very, very low for setosa. Now, Let's look at the second species of flower, namely versicolor. Look at the central line here. The central line here represents the median or the average value. This value is way higher as compared to the average value for setosa flowers. Approximately, the average value of petal length for versicolor is around 4.5. Finally, I can look at the third group of flowers, namely virginica. When you look at virginica, let me draw your attention to the central line here, which represents the mean petal length for virginica. Let me look at the y-axis value. It's around 5.5, approximately 5.5, which is the largest value as compared to the other two species of flowers. So when you look at this graphical display, it is quite clear that the mean petal length for the three species of flowers is not the same. It is very, very different. Now, is there a statistical procedure through which you can compare and say, yes, the mean petal length for the flower species is very, very different? The name of such a statistical technique is called as post hoc test. We perform the post hoc test after one-way analysis of variance to do pairwise comparisons and to identify which is that one group or two groups which has a mean value significantly different from the rest. To do this, let me again go to the analysis tab. You can see here, there's an option for compare groups. I'm going to click on the drop-down menu here. There are a lot of options here like t-test, ANOVA. I'll ignore each of these. Let me scroll down. You see a very interesting option which is called as Tukey HSD. Tukey HSD stands for Tukey's Honest Significant Difference. Here we will be comparing and doing a pairwise comparison. We will be making a pairwise comparison between, or shall I say, we'll be doing a pairwise comparison among the three species of flower. Let me choose Tukey HSD. This is the new window that opens up. This window is called as the Tukey HSD. The variable that I will be choosing here is petal length in centimeter. And under the category section, I will be selecting species. So I'll be choosing petal length along the variable, species under the category section. Let me now hit the OK button. We have to wait for a couple of moments so that StatCraft can give us the output. Let me scroll down to look at the output of pairwise comparison. This is the earlier output. Yes, this simple table is the table for Tukey HSD. What we are doing here is we are doing a pairwise comparison. You can see here group 1 versus group 2. In the first row, we are comparing between versicolor and virginica. Look at the column heading here. It says mean difference of 1.2, which means that when you are looking at the average petal length for versicolor and comparing it with the average petal length for virginica, there is a mean difference of 1.2 centimeters. Further, the fourth column here is the p-value. What is the p-value here? The p-value is 0.001, which is clearly less than 0.05. Since the value for p is less than 0.05, we can reject our H0 and conclude that there is a significant difference in the mean petal length for versicolor and virginica. You can also see lower confidence limit and the upper confidence limit for the mean difference. This simply tells me that the mean difference of 1.2 will lie within the range. It will lie between the range of 1.08 and 1.4. The decision here is, you can see here, the last column is reject. We have already interpreted the p-value, so we don't need to again look at the last column. Let's look at the second pair. The second pair of flower species that we are comparing is Setosa and Virginica. You can see here the mean difference is 4.08 centimeters, which is a big difference. Setosa, if you recall, has a lower value for petal length. Virginica has a higher value for petal length. What is the p-value here? The p-value here is 0.001. Again, this value is less than 0.05, and therefore we again reject our null hypothesis and conclude that there is a significant difference in the mean petal length for Setosa and Virginica. The third pair of comparisons that we will be making is for Setosa and versicolor. So this is the pair of flower species which we will be comparing. You can see here the mean difference for these two species is 2.79 centimeter. What is the p-value here? The p-value here is 0.001, which is clearly less than 0.05. Since this is less than 0.05, we will again reject our null hypothesis and conclude that there is a significant difference in the mean petal length between Setosa and versicolor. So this is what we can extract by doing a pairwise comparison using the Tukey HSD. In today's video, we looked at three important things. In the first stage, we looked at one-way analysis of variance. In the second stage, we looked at box plot. And in the third stage, we performed Tukey HSD. With this, I have come to the end of today's video. I request you to subscribe to my channel, also like and share my videos. Thank you very much for watching this particular video. Have a great day ahead.